Hi everyone. As we know, the Earth's population is rapidly increasing. And with this rapid increase in population, there's come an increase in demand for new machines and technology. Now these machines and technology are made out of raw materials, things like gold, tin, aluminium and lots of other different materials. But as we have more demand to build these things, we're actually having a shortage of the raw materials to actually make them. You combine this with the really poor recycling we tend to have here on Earth, where, for example, we don't recycle mobile phones that well. What's going to happen is that eventually we're going to start running out of these materials and we're not going to be able to build new machines and technology. So where do we go if we start running out of these materials down here on Earth? Well, we might have to look upwards and start considering what it'd be like to mine an asteroid for these raw materials. So you may know that space agencies like NASA and other companies have been researching into mining asteroids to see how likely it is that we can do it, what technology we might need, and how much money they can make from it. But this is still a relatively new field. So what do we know about mining an asteroid so far? But first of all, what are asteroids? So asteroids are lumps of rock, dust, ice and metal that are floating around our solar system, orbiting around the sun. Now, when we say asteroid mining, we're not actually limiting ourselves to just asteroids. Comets are actually the same as asteroids, it's just that when they pass close to the sun, you see a comet's tail. But a comet can turn into an asteroid can turn into a comet, it's just the naming of the actual system. Now, asteroids and comets are remnants of planet formation in our solar system. In the early solar system, there was a giant disk of dust, ice and material orbiting around the sun, and this formed together to build the planets. But the leftover material formed asteroids and comets in our solar system. And what this means is it's likely that asteroids and comets contain the same kind of metals that we have down here on Earth. But just like on Earth, there's a good chance that some of these materials are deep within the surface of the asteroid or comet, so we have to try and find a way to get down towards this material. But how do we do this? Well, it's unlikely we can use the same technology as we used to mine down here on Earth, this idea of miners with pickaxes and mining tunnels. Instead, it's more like to take a more advanced and technological approach. Now, it's possible that we can use some of the technology we use down here on Earth, such as drilling or explosive, to break apart the asteroid or get deep beneath its surface. Perhaps slightly more advanced technology, such as lasers, to try and break down the asteroid. But then again, comets and asteroids, as they approach the sun, begin to melt due to the energy from the sun. Now, asteroids and comets are made of ice, so what happens is when they approach the sun, this ice melts and it breaks apart the comet or asteroid. So actually, the sun may be able to help us by breaking apart the asteroid or comet for us. Well, whatever way you do it, someone's going to have to operate the machinery or the equipment that's on the asteroid that's used to break it apart or to suck up all the valuable material. So what do? Do you put someone living on the asteroid for a small amount of time? Just like on the ISS, they're going to have constant supplies of oxygen, food and water. Plus again, the surface of the asteroid is pretty insecure, so you're going to have to try and find some way of getting a stable living place on the surface. Then again, perhaps you'll have someone that just orbits in a spacecraft near the asteroid and they can remotely operate the machinery. But why bother sending anyone to an asteroid? The robotic missions on Mars show that we can remotely control robots to do many of the tasks that humans can do. You can just spend your time sat at home controlling the robots, also in the background watching your favourite UKAstroNut videos. But however you decide to drill, you're going to have to come up with a very clever way to get the material back down here to Earth. An upcoming NASA mission, Asteroid, will bring back 60 grams of material from space at a cost of $1 billion. Now obviously this is far more than it costs to get down here on Earth at the moment. But as the resources begin to dwindle here on Earth and our technology improves, making it cheaper to bring material back from space, this actually isn't going to look like too bad an idea. But even if you manage to solve all of these issues, there's still one big one remaining, and this is the legality issue of who owns an asteroid. Now we have enough problems down here on Earth deciding who owns land and who owns resources, but up in space this is even more difficult. Because there's no region of space that can be owned, how do we decide who owns what asteroid? More importantly, let's assume something goes wrong. An asteroid breaks apart and some of it crashes down here on Earth. Who's responsible for this? Can someone actually take responsibility for it? This is surely one of the biggest problems that asteroid mining will have to face in the future before it can become a reality. Well, the little work done in this area of research so far, it's unlikely that NASA is going to be asking for applications for asteroid miners at any point soon. But unless technology and culture changes, we are going to start running out these valuable commodities. And strangely enough, mining a piece of rock and ice in space, an asteroid, may well be a reasonable solution to this problem. So thank you very much for watching. Don't forget you can like, subscribe to the video, I really appreciate it, and leave any comments. I always try and get back to comments if you have any questions or feedback, please do. You can check me out on Twitter at UKAstroNut, but otherwise, thanks for watching guys, and I'll see you guys soon.